Hello and welcome to this tutorial about the Ranger3 3D Vision streaming camera from SICK. In this video we will show you how to calibrate the Ranger3 in a few simple steps. To do this we are using the SICK calibration and configuration software Ranger3 setup. Let's start by setting up the camera. The most common laser camera geometry is the reversed ordinary setup, and this is what we will cover in this video. Make sure that the laser is correctly mounted, orthogonally with the conveyor. The next step is to set the focus and the area of interest, which is the part of the sensor where we need to have calibrated data. Therefore, you place the object you want to inspect under the laser line. Then, open the Ranger3 setup software, connect the camera and go to the Sensor tab. To adjust the area of interest, enable the 3D extraction area. Set the sensor parameters to get a good image of the object. Open or close the aperture of the lens. A more closed aperture will lead to a sharper focus in a larger range. If you are satisfied with the lens focus, the aperture and the laser focus, you can move on to the calibration. However, remember that all these parameters affect the calibration, and after changing them, calibration has to be redone. We will now show you two different methods of calibration, Sawtooth and dot wedge. These methods are the ones which are supported by the Ranger3 setup software at the moment. The advantage of the Sawtooth method is that it's slightly easier to use. It is also better to use for a large field of view, since you can produce a very big sawtooth target. Remember, it's always a good idea to validate your calibration by measuring on your samples to see what performance you get. The dot wedge method is instead recommended for a very small field of view, because it can be produced in a very small size. No matter which method you use, the calibration model achieved will be the same. Let's start with the Sawtooth calibration. To begin, you need to place the target under the laser line, and the target has to be aligned with the laser plane. For the camera configuration, go to the Sensor tab. The peaks and valleys need to be distributed within the whole area of interest to ensure a good calibration. Furthermore, adjust the exposure time and save a number of sensor images to cover the needed field of view. If you are using a Scheinflug adapter on the camera, there is a checkbox in the calibration settings that needs to be set. To run the calibration, select the image folder, set the tooth width and height, which is indicated on the sawtooth target. In our case it would be 20 and 10. Then click on Calibrate. After that, go through the feedback images and verify the calibration. If you have followed the previous steps, now save the calibration. And that's how you calibrate with the Sawtooth method. Let's continue with the dot wedge calibration method. Here, the target should be oriented away from the camera to avoid direct reflections. And it is important that the dots are aligned with the laser line. To configure the camera, go to the 3D Scan tab and enable Reflectance and Encoder. Make a scan, check the reflectance and save the image. After that, go to the Calibration tab. Set the dot distance X and Z. the dot distance X is specified on the dot wedge target. Z has to be calculated. Finally, click on Calibrate and check the feedback images and again verify the calibration. The dot wedge angle is often hard to measure, and you almost always need to adjust the dot distance Z in order to get the correct height scaling. And that's how you use the dot wedge calibration method. Now you need to apply the calibration. First, go to the Cameras tab and select the calibration file. Secondly, click on the 3D Scan tab and set the output mode and Y resolution. Make a scan. And the last step is verification. Scan an object with known height and width, for example a gauge block. After that, measure the object and if needed, adjust the calibration parameters and redo the calibration. And now you know how to calibrate the SICK Ranger3 3D Vision streaming camera.